Hello everyone, this is my project on credit risk modeling under Pregrad. As you can see, initially to begin with, I have imported all the necessary libraries like NumPy, Pandas, Matplotlib and Seaborn. I'm also using sklearn for the machine learning part. First, we read the dataset that has been provided by the Pregrad team. Next, we perform EDA operations on it. As you can see, this is the existing shape of the dataset. Then I study the columns. Uh, Age through pay outcome success are the features, and the loan status label is the target variable. I've studied the info, and then using the dot describe function, I've studied the statistics of the data in the table. This is our target class, loan status label. By studying the value counts of loan status label, I've noticed a bigger problem that there are around 35,000 negative results and only about 5,000 positive results. So to make that correct, this is an imbalanced data set. So to make that correct, I have used weighted averages of the two, so that the data set is cleaner and there is a better prediction. Thankfully, there were no null values, so the data was relatively cleaner. Uh, I I have dropped all the duplicates from the data set to make the prediction more accurate. Next, I've noticed the value counts in all the columns respectively, and I see that there is no disparity there. Next, we move to outlier analysis. I've used the quantile outlier analysis process to clear out any outlier that will sort of bring an error in the prediction. You can see after removing the outliers, this is the existing shape of the table. Next, we move to feature selection, where I've created a correlation matrix of the features with the data in the data set. To visualize this better, I've also put it in a form of a heat map to study it better. Next, I've moved to building the ML model. I've used 4 models here. Uh, First, I split the data set into the standard 80-20 train and test using the train test split. My test size is 20% of the data set. Then, using a standard scaler, I have scaled the test and train data accordingly. My first model is a logistic regression model. It works on a simple cost function. As you can see, on training, my logistic regression model has been trained here. Then I've used decision tree where my class weight is balanced. Next, I have used an adder boost classifier model, and then I've used a random forest model. I have studied the score of all the 4 models, and it is here. Logistic regression model gives around 67%, gives about 66% on the test data. The decision tree gives about 83% on the test data. The adder boost model gives about 82% on the test data, and the random forest gives about 89%. So as you can see, random forest is probably the most accurate model for our purpose here. But it might be overfitting, so we'll tune the model here. On using the following parameter grids, I have sort of changed the parameters here, and then on using my random forest classifier model, this is the output that I've gotten. This is the confusion matrix for my model, and my accuracy has come to about 0.9, which is a 90% for train and about an 85% for testing. So this shows that our model is close to right predictions. Then I've made a statistic of all the data in the random forest model and a heat map for better understanding. This is my project, and this can be further improved by using more ML models. Um, Lastly, I'd like to thank Pregrad for helping me through this course, and I think I'm more confident in doing data analysis and using AI ML. Thank you. माँ की चूत, bro. This